Hi, welcome dear students. Some more interesting problems on logarithmic inequalities we will discuss, because these are somewhat logical problems. That's why I felt that more number of problems, more number of models, explanation will make you stronger in the concepts by observing these models, right? On that part, now one problem, log of to the base sine pi by 3, okay, to the base x square minus 3x plus 2 greater than or equal to 2, greater than or equal to 2. This is what our problem. We written that sine pi by 3 means sine 60 degrees. Sine 60 degrees value is root 3 by 2. That's why log of root 3 by 2 to the base x square minus 3x plus 2 greater than or equal to, these 2 we are writing as log of root 3 by 2 whole square to the base root 3 by 2, right? Then it becomes 2 into log of same value to the same base. Then it becomes 2 into 1, 2, like that. Nice. One more thing you have to observe, this root 3 by 2 value is there, the base, root 3 means 1.7, around 1.7 by 2 will lie between 0 and 1. This will lie between 0 and 1. That means the base is lying between 0 and 1, means the input value, you know that here greater than or equal to will become lesser than or equal to you are going to get. That's why x square minus 3x plus 2 is lesser than or equal to, okay, this value you have root 3 by 2 whole square, that is 3 by 4, like that, right? Now since this is a positive quantity, we can cross multiply like this, then we will get that, right, 4x square minus 12x plus 8 lesser than or equal to 3. Now you will get a beautiful quadratic inequality expression, 4x square minus 12x plus 8 minus 3 lesser than or equal to 0. That is now 4x square minus 12x plus 5 is lesser than or equal to 0. This is now 4x square minus 10x minus 2x plus 5 lesser than or equal to 0. And this, if you take 2x common, 2x minus 5 minus 1 if you take common, 2x minus 5 lesser than or equal to 0. Now this is 2x minus 5 into 2x minus 1 lesser than or equal to 0, right? That means it is lesser than or equal to 0 means the critical points and the roots are 2x minus 1 equal to 0 means 1 by 2 and another root is 5 by 2. Lesser than or equal to 0 means 1 by 2 and 5 by 2 is included. In between the total solution you are going to get. That is what we written, x belongs to 1 by 2 comma 5 by 2. This is what the solution set. And you have to be very careful, not only this is the solution set, you are having logarithm of some expression x square minus 3x plus 2. You observe this, this x square minus 3x plus 2, right? X square minus 3x plus 2 you can write as x minus 2 into x minus 1. Okay, this equal to 0 when x equal to 2 comma 1, like this. That means for 1 and 2, okay, this is for x is equal to, you have got 2 comma 1, like this. For x equal to 2 and 1, this becomes 0 and logarithms are not defined for 0. That's why you need to exclude these 1 and 2 values. That's why after excluding that, you have got now the solution set as like this, right? You have x belongs to 1 by 2 comma 5 by 2 minus of 1 comma 2. This you can write as 1 by 2 to 1, right? This is included here, 1 is excluded, union 1 to, right, 2 is excluded, union 2 to 5 by 2, like this. This is what the solution set after excluding 1 and 2. This is what, these both are same only, these both are same, this only we can write as like this. Just excluding 1 and 2 we have written the solution set as like this. This way you will get this particular problem, right? Fine. Right. Now one more fabulous problem. The second one, solve modulus of 4 minus log x to the base 2 greater than 2, like, right? How we will solve this particular problem? You see, we have one modulus inequality result property, modulus of a greater than 2. That implies a less than minus 2 and a greater than 2, right? Now using the same fact, now in the place of a you are having 4 minus log x to the base 2. Now this is 4 minus log x to the base 2 less than minus 2, and 4 minus log x to the base 2 greater than 2, like this. Now let us take each one separately and solve and get the solution set. Now 4 minus log x to the base 2 plus 2 is less than 0, like this. That means minus log x to the base 2, 4 plus 2 becomes 6, 6 is less than 0. Now this is log x to the base 2 minus 6 greater than 0. Why? By multiplying minus sign on both sides, you will get log x to the base 2 minus 6 is greater than 0. Now this become log x to the base 2 greater than 6. We have like this. Log x to the base 2 greater than, we can write 6 as log 2 power 6 to the base 2. Now base 2 is greater than 1, then it will maintain same inequality, greater than only. That means x is greater than 2 power 6 is what the required solution in this case. Now another case is a greater than 2. That means here a is 4 minus log x to the base 2 greater than 2. That means 4 minus log x to the base 2 minus 2 greater than 0. That means 2 minus log x to the base 2 greater than 0, like this. Right? Now by multiplying a negative sign on both sides, we get log x to the base 2 minus 2 less than 0. Now log x to the base 2 is less than 2. Now you can write this 2 as log 2 square to the base 2. Here also 2 is base greater than 1. X less than 2 square. That means x less than 4. This is now 2 square means 4, 2 power 6. We have x less than 2 square means this. And x greater than 2 power 6 means this. Therefore our solution set is x belongs to 0 to 4 union 64 to infinity. Here we have taken only from 0 to 4. Y means we actually minus infinity to 4 we have to take, but minus infinity to 0, okay, including 0 we have extracted and excluded, because logarithm, okay, logarithms whose x values, okay, logarithms are defined for positive values, that's why negative values are excluded. That's why x belongs to now 0, 4 union 64 to infinity you are having. This way you will do this wonderful and fabulous problem, right? This gives you, right, the approach how we are dealing these particular problems by looking, and you students clearly write in your classworks notebooks such that you will have a very good idea about these logarithmic inequalities problems. You can able to do wonderfully all these problems, right? Another interesting problem on this logarithmic inequalities: solve log x to the base 3. These are two system of equations, right? This is one equation they given, this is another equation is given. This is involving into two variables x and y, like that, and we need to find x value and y value, like that. Now let us take the first equation, log x to the base 3 plus log y to the base 3 equal to 2. 2 we can write as log 3 square to the base 3. That means log 9 to the base 3 plus log 2 to the base 3. That is equal to, right, log m plus log n, that is log mn. Mn means log 9 into 2, that is log 18 to the base 3, like that, right? Now this is log x to the base 3 plus log y to the base 3 means log xy to the base 3, right? This is equal to log 18 to the base 3, right? That means you have got xy is equal to 18, like this. Xy is equal to 18, right? Now another set of equation, that is what this log x plus y to the base 27 is equal to 2 by 3, right? Log x plus y to the base 27 equal to 2 by 3. We convert this into exponential form. If you convert this into exponential form, 27 whole power 2 by 3 is equal to x plus y. Now this 27 we can write as 3 cube whole power 2 by 3 equal to x plus y. This 3 will cancel, x plus y is equal to 9, like this. Now you got nicely two equations. One is x plus y is equal to 9 and xy is equal to 18. Now let us solve this using algebra technique to get x value, y value. X plus y is equal to 9 means y is equal to 9 minus x. Let us substitute this y in this equation, xy equal to 18. X into y. Y is what? 9 minus x is equal to 18. You multiply 9x minus x square this 18 you bring left side, minus 18 equal to 0, and multiply by negative sign, you will get x square minus 9x plus 18 equal to 0. Now this is x square is a quadratic equation, multiplied means 18x square, adding means minus 9x. 6 minus 6 and minus 3x, minus 6x and minus 3x are the suitable terms which satisfy these conditions. Therefore x square minus 6x minus 3x plus 18 is equal to 0. Now you take x common, x minus 6 minus 3 take common, x minus 6 equal to 0. Now x minus 6 into x minus 3 equal to 0. Now x equal to 6 comma 3 are the values you have got here. Now we want to get their corresponding y values. When x is equal to 6, y is equal to 9 minus x. That means 9 minus 6, that is 3. That means you have got x 6, y 3, 6 comma 3, like that. Next, when x is 3, y is equal to 9 minus x, 9 minus 3, that is 6. That means 3 comma 6. These are the set of values of x and y you have got for this particular system of equations in logarithm, and the approach you understood how you will be getting that. From the first equation you have got one equation, and the second equation you have got another equation. We solved them algebraically and got the values of x and y, right? Like this we do this particular problem, right? Now the fourth problem, solve 1 by 1 plus log x plus 1 by 1 minus log x greater than 2. Okay, this is a different kind of problem. Okay, we do this one. The solution part, you take log x is equal to some other variable, it has y, like this. Now 1 by 1 plus y plus 1 by 1 minus y greater than 2, like this. Now you take LCM 1 plus y into 1 minus y, that is 1 minus y square. This is now 1 minus y plus 1 plus y. This minus y plus y will cancel. This is greater than 2. Now 1 plus 1, that is 2. 2 by 1 minus y square greater than 2. Now we can cancel this 2 on both sides because it is a positive quantity. That means we can divide by 2 on both sides. Then we will get 1 by 1 minus y square is greater than 1, like this, right? Now how we will do? By the method of intervals concept, like this is 1 by 1 minus y square minus 1 greater than 0, like this. Now 1 minus y square you are having here. This is now 1 minus of minus 1 plus y square greater than 0. 1 minus 1 will be cancelled, and y square by 1 minus y into 1 plus y greater than 0, like this, right? And here you see y square is a perfect square. Y square is a perfect square. You will get, okay, we can transfer to the right side such that we will get 0 by y square, that becomes 0. Now this is 1 minus y into 1 plus y we have here. Okay, to do this particular problem now, okay, we want to make the denominators as perfect square such that we will get okay, that is a positive quantity, we can transfer to the right side. Now you just multiply and divide by 1 minus y into 1 plus y. That means you have got now 1 minus y into 1 plus y greater than 0, like this. Now we multiply by minus sign on both sides to this, then we will get y minus 1 into y plus 1 is less than 0, like this. Y minus 1 into y plus 1 less than 0. Now you have got here minus 1 and plus 1. This is minus infinity to plus infinity you have, right? Between these two roots you will be getting the solution set for this, right? That means we have got the y value is lying between minus 1 less than y less than 1. This is what we are going to have here, like this. Minus 1 less than y less than 1. That means minus 1 less than, right? Y is what? Log x. Log x is less than 1, like this. Okay, let us take both. Now minus 1 less than log x means log x is greater than minus 1. You have here one thing, right? Suppose if you take it is to the base 10, like this. Now you can write this as log x to the base 10 greater than, okay, because minus 1 is less than log x. We take that part, that piece. log x to the base 10, okay, greater than minus 1. This we can write as 10 power minus 1 to the base 10 like this. That means x is greater than 10 power minus 1. That is nothing but 1 by 10. We have got one solution. X is greater than 1 by 10. We have got like this. Now we want to get the other thing. Let us do here this, right? Let us do here like this here. Fine. Now this if we do here, what we are going to get is right, log x is less than 1 like this. Log x is less than 1 to the base 10, and this we can write it as log 10 to the base 10 like this. That means x is less than 10, we will be getting like this. Okay, x is greater than 1 by 10 and x is less than 10. Now the total, the solution set, we can say that x is greater than 1 by 10 means, okay, 1 by 10 is less than x less than 10. This is what the total solution set for this problem. 1 by 10 less than x less than 1 by 10 less than x less than 10 is what the solution set for this particular problem. Now another problem, okay, which is from the material. Solve x power log x to the base 3 minus 4 is equal to 1 by 27, right? This is now log 1 by 27 to the base x. You convert this into logarithmic form. Here you have something, x power something is equal to 1 by 27. We convert that into logarithmic form. Then what we have? Log 1 by 27 to the base x is equal to log x to the base 3 minus 4 like this, right? This is now log 3 power minus 3 to the base x equal to log x to the base 3 minus 4 like this. And we can write this as minus 3 into log 3 to the base x, that equal to log x to the base 3 minus 4 like this. And this we can write as minus 3 by log x to the base 3 equal to log x to the base 3 minus 4 like this. Now you take log x to the base 3 as y like this. Now this becomes minus 3 by y is equal to y minus 4. Now let us simplify this by cross multiplying and we will get a nice quadratic equation. This is now minus 3 into 1 minus 3 equal to y square minus 4y like that, right? This is now y square minus 4y plus 3 equal to 0 like this. Now this quadratic equation, how it can be achieved is solved. Multiplied means 3y square, adding means minus 4y. The suitable terms are y square minus 3y minus y plus 3 equal to 0 like this. Now this becomes y into y minus 3 minus 1, if you take common, y minus 3 equal to 0. Now y minus 3 into y minus 1 equal to 0. Y is equal to 3 comma 1 are the roots you have got. But we have taken y is equal to what? Log x to the base 3, right? Log x to the base 3 equal to 3, then x is equal to 3 cube. Another one, log x to the base 3 equal to 1, then x is equal to 3 power 1. By converting these logarithmic forms into exponential forms, right? X is equal to 3 cube and x is equal to 3 power 1. Therefore you have got now x is equal to 27 comma 1. These are the two required solutions of x values we got from this problem. This is a different kind of problem, my dear students. You can solve whenever they give like this. You try to convert into logarithm, then you will get the idea, and you convert everything into log x to the base 3. Take log x to the base 3 as some variable y or something. You get a quadratic equation, solve it, express once again that in terms of x by converting those log into exponential forms. From that you will get the x values, right? Another important problem. Some students are confusing how to do these particular problems. That's why I intended to give solutions for these type of problems. Solve x power log x to the base 2 is equal to 4x. This is also, my dear students, this is in exponential form. We convert that into logarithmic form, right? Solution: log 4x to the base x is equal to log x to the base 2, right? This exponential form we converted into logarithmic form. Log 4x to the base x is equal to log x to the base 2, right? Now this log 4x to the base x we can write as log xy log AB you can write as log A plus log B to the same base x. That's why log 4 to the base x plus log x to the base x is equal to log x to the base 2, like this. And log 4 you can write as log 2 square. Log 2 square, that we can write as 2 into log 2 to the base x plus log x to the base x. Logarithm of any number to the same base become 1. That's why plus 1 is equal to log x to the base 2, like this. Now this is 2 by log x to the base 2 plus 1 is equal to log x to the base 2. Now you take log x to the base 2 as y, right? By taking log x to the base 2 as y, now 2 by y plus 1 is equal to y you have got. Now let us take LCM here. Y and 1, LCM is y. Now 2 plus y is equal to y by 1. Now you do the cross multiplication. From that 2 plus y is equal to y square. Now y square minus y minus 2 equal to 0. Now this is y square minus 2y plus y minus 2 equal to 0. Now if you take y common, y minus 2 plus 1 into y minus 2 equal to 0. Now y minus 2 into y plus 1 is equal to 0. Now y is equal to 2 comma y equal to minus 1, right? Once we have got y is equal to 2 comma y equal to minus 1, y equal to 2 means log x to the base 2 equal to 2. That means x is equal to 2 square, that is 4, right? And when y is equal to minus 1, okay, log x to the base 2 is equal to minus 1. That means x is equal to 2 power minus 1, that is 1 by 2. Therefore here x is equal to 1 by 2 comma 4 are the two required solutions that we have got for this problem. You can even back substitute and you can verify also. X is equal to 1 by 2 comma 4 are the two required solutions, those we have got for this particular problem, right? Thank you very much for these problems, my dear students. The next we are going to discuss exponential inequalities is what our next topic that we will discuss. Once we complete exponential inequalities, we will enter into coordinate plane, coordinate geometry topic. Next trigonometry, like that we will enter. Thank you for watching. Please subscribe, share it and like it, right? Thank you very much.